planet is filled with life. Its diversity is amazing and fragile. Some 66 million years ago, this life was born from disaster and chaos. While on land, the giant dinosaurs ruled supreme, from space came a monstrous asteroid to cause one of the worst catastrophes our planet has ever known. This apocalypse wiped out the giant dinosaurs and brought many plants and animals to the verge of extinction. But another world would arise from the ashes. Our world. Unexpected creatures would write this new chapter of life on Earth. Who were these survivors? How did they come to conquer our planet? In a rocky desert in the heart of Colorado, a team of American and French paleontologists, led by Tyler Lyson, has found a treasure trove of plant and animal fossils that tell the story of their ascent. Here in Coral Bluffs, the origin of the modern world is being revealed.
Coral Bluffs has the best fossil record for understanding what happened after Earth's last mass extinction.
Fossils of mammals, turtles, crocodiles, birds, and plants are the remarkable evidence of how life survived and quickly diversified from the rubble of the dinosaur kingdom.
Below that line, we find lots of dinosaur fossils, and above that line, we find no more dinosaur fossils.
These exceptional fossils record the coevolution of species in the first million years after the cataclysm caused by the asteroid. In this hostile landscape 100 kilometers south of Denver, Tyler Lyson is going back in time to the world of the asteroid survivors. After a first successful expedition in 2016, he and his team of fossil hunters are now back in the field searching for new animal and plant species to help reveal the origin of the modern world, our world, the age of mammals.
Creamy of what, but it's definitely a skull.
This is a revolution in the world of paleontology. Never before have so many plant and animal fossils from the period, particularly ones so complete, been identified.
Oh, you have some too?
Yep.
Wow!
Among them, the crocodilian Borealosuchus, the turtle Axostemus, the small mammal Mesodma, and last but not least, the bird Asteriornis, found in Europe.
I always thought these fossils would be found in some far-flung desert, well away from where I was. Before I went to some of these far-flung deserts, I thought, well, I should go look at some of the rocks in my own backyard. And that's what brought me to Coral Bluffs. This amazing treasure trove of fossils were all sort of hiding in plain sight. And so over the last few years, my team and I have built up the best record for understanding what happened after Earth's darkest hour.
In the rocks of Coral Bluffs, Tyler's team of paleontologists are getting closer to this darkest hour. Those last moments when the 150 million year reign of the dinosaurs was annihilated. When a gigantic 14-kilometer wide asteroid, almost twice the size of Mount Everest, crashed into Earth. "66 million years ago, Coral Bluffs looked very different, and its forests were the hunting ground of the king of dinosaurs, Tyrannosaurus Rex. This fabled predator stood apart from all other species, so absolute was its reign. Even the mighty Borealocicus would not dare challenge the king of dinosaurs for prey, and waited its turn. Safe in its absolute rule, T-Rex was blind to the danger that first appeared as a small light in the sky. The asteroid hit the Earth off the Yucatan Peninsula of Mexico, near the modern-day town of Chicxulub. The impact, 1 million times more powerful than the Hiroshima bomb, pulverized billions of tons of molten rock, more than 100 kilometers high into the atmosphere. In these lands ravaged by fire, all large creatures were dying. Only small land creatures weighing less than half a kilo, as well as much larger aquatic reptiles, were able to weather the storm and survive the cataclysm. Darkness descended upon the Earth in a hurricane of dust, ash, and debris. 75% of living species disappeared in a matter of days. A deathly shroud enveloped the Earth. Only the sound of the dust storms broke the funereal silence. Before the arrival of Tyler Lyson's team, fossil hunters had long been searching for a site that could reveal the days after the cataclysm. Until 2016, they had found no complete fossil record that documented the events after the asteroid strike, and Corral Bluffs didn't seem like the best place to look. So how did this scientific adventure begin? Tyler Lyson's childhood passion for dinosaurs led him to travel the world in search of animal fossils that had survived the asteroid strike. When he arrived at the paleontology department of the Denver Museum of Nature and Science, he pored over the fossils stored in the collection located in the museum's basement, and one discovery caught his eye.
This is a partial skull of a mammal called Carciopticus that was found in 2014 by one of our volunteers, Sharon Melito. I saw this specimen shortly after I got a job here at the Denver Museum of Nature and Science, and it was this specimen that got me really excited about going out to Corral Bluffs to see if I could find more mammals that were just as complete as the skull that Sharon had found.
With the instincts of a fossil hunter, Tyler was excited by this draw and asked Sharon Melito where she had found it. The paleontologist's enthusiasm showed her that this discovery could be the starting point of a scientific revolution.
Yeah, I found it right up there in a real muddy section, and it was just sitting right there. It was the only concretion in the whole area.
Barren, and then one rock.
When I picked it up, I mean, it looked like nothing from the top side when I saw it, and then I picked it up and turned it over, and I was shocked. I didn't know it was going to be an important fossil. I just knew it was the best fossil I'd ever found. The teeth weren't cracked. They were all right there. It was amazing.
I'm thinking like, well, if Sharon, found a skull this nice, if there's one out here, there's got to be more out here.
But to find others, You have to be able to spot them in this vast area of sand and dust. Luckily, the mammal specimen discovered by Sharon Melito held a fundamental clue that tipped Tyler off about where the Corral Bluffs fossils were hiding.
So this specimen was pretty special because all of the teeth were showing, they were sticking out of the concretion, and then there was a little bit of concretion on the outside. So this was one of the clues that led me to go down to Corral Bluffs and pick up these concretions and crack them open, not really thinking I'd find much.
The fossils were hiding in plain sight, inside a matrix of stone called a concretion. Previous expeditions had totally ignored these concretions, and nobody had found the key to the treasure of Corral Bluffs before Tyler Lyson.
Hey, Tyler.
Hey, Kirk, how's it going?
Long time no see.
Good to see you, yeah.
Kirk Johnson, now director of the Smithsonian Institution's National Museum of Natural History and a great friend of Tyler, has also traveled the hills of the Bluffs and held these characteristic concretions in his hands.
I spent almost 20 years visiting Corral Bluffs on a regular basis, mapping the geology, looking for fossil leaves, collecting fossil leaves. We knew there were bones, and occasionally I'd find a little bit of a bone here, a little bit of a bone there. We saw the concretions. I broke them open. I thought, oh, these are nothing. Threw them away. I know I threw away a skull.
Yeah.
It's so important to learn how to see a site and learn how to recognize what fossils look like. And that's what he did at Corral Bluffs. It's so amazing. And now that he knows how to recognize them, they just come pour out of the ground.
This thing is insane, though.
Exploring the fossils of Corral Bluffs gave Tyler Lyson the key to the whole treasure chest. But telling the story of these survivors meant identifying and dating them, understanding their environment, and discovering how life rebounded after the fall of the asteroid. To solve this mystery, the paleontologist has brought together a team of specialists and is on his way to join them.
This is an interval of time that I've always been interested in. I grew up in North Dakota, which is the best place to understand the extinction of the dinosaurs. But what we don't have a good record of is what happened after the extinction of the dinosaurs. So it's been sort of like this black box. Nobody knew what happened afterwards.
They have already been hard at work for a week in the field, looking for as many clues as possible.
So we found a number of things this week. This was the very first specimen that was found, and Jake found this as his first day out in the field. Could be a really, really important one. We found that over here in Skull Valley. And then I picked this one up the other day, and this was in the gully, laying down just like that, and I found a little...
As well as unearthing other animal fossils, plant fossils also need to be collected to get a complete picture of the environment and its evolution.
Yeah. So we found some legume localities over in this area, and these are going to be some of the oldest legumes ever found on Earth.
Great. Well, Antoine and the crew are going to go over to this interval here to try to pinpoint the KPG boundary. Natalie and the crew are currently cutting out a giant soft-shell turtle from over in here. So I think we've got a lot to do. So shall we? Let's get going.
It was in one of the ravines at Corral Bluffs that Tyler Lyson's practiced eye spotted some pale-colored concretions. In them was the fossilized shell of a giant turtle, sticking out from an eroded hill. Could Axistemis, one of the survivors of the asteroid, be hidden here? To be sure, it has to be removed from deep in these ravines. Breaking rock means using heavy tools. That's today's mission for Natalie Toth, Jake Wilson, and Tyler.
All right, guys, well, we've arrived at the turtle site. This is a really cool turtle because it's the largest animal that survives the mass extinction. So it has a diameter of about a meter. It would have weighed about 150 kilograms.
After 66 million years buried underground, what might be left of this ancestral turtle? The team expects to discover a piece of shell and perhaps a few scattered fragments of bones. Little do they know what this pile of debris has in store for them.
It's a tougher excavation, which is, like I said, fine. We're getting other bits of bone, but it makes us nervous. So we have the back of the shell here, back where my brush is. I found parts of the hand right here, and then Natalie just found a small bit of bone right here, which is part of the, I think part of the neck. Where's that piece?
And what was really exciting is we found the skull and the lower jaws from this turtle, which was completely unexpected until just a few hours ago.
It's hard to recognize the bones because they're completely covered with this concretion.
This is the back of the turtle's skull, and there's the tip of the nose, tip of the snout, and it's upside down. And just next to it over here, this is the lower jaw, which is also upside down. So this is the very back points that would attach onto here. And then this is the top or the tip of the lower jaw, which would attach up here.
To protect the fossil, Natalie and Jake cover it with burlap soaked in plaster. The plaster jacket protects and holds the precious fossil together while removing it from the ravine. It is only back at the Denver Museum and with the right tools that the outer layer will be carefully removed, revealing the skeleton of an animal that was alive more than 65 million years ago.
Turtles are incredibly resilient animals, but when the asteroid struck 66 million years ago, but the things that seemed to survive were things that had, one, a slow metabolism, two, were quite small, and then the last important thing were the fact that turtles lived in the water. So animals that lived in freshwater ecosystems like rivers, ponds, and streams, they do remarkably well across the Cretaceous-Paleogene boundary.
The slow metabolism and underwater lifestyle of Axostemis the turtle helped it survive the day of the asteroid impact. And along with a few other survivors, it had to endure almost a decade of nightmarish environmental conditions, which didn't make life easy. In the upper atmosphere, the soot and aerosols released after the impact blocked out the sunlight. For several years, the planet was plunged into darkness, followed by a period of twilight. Photosynthesis was almost impossible for plant life. In North America, more than 50% of plants became extinct. It was in this nuclear winter, when continents and oceans grew colder, that survivors took their first steps on the path to survival. For 150 million years, the dinosaurs completely dominated the planet, relegating small mammals to a minor role in the overall ecosystems. However, it was the smallest of these little-known creatures, like the Mosadma here, who would help repopulate the Earth and give rise to the world we know. It was its underground life that helped it survive the catastrophe. Wary, agile, and quick in the shadow of the giants it feared, it had long led a clandestine life. Now free, darting from burrow to burrow, this might be the very first time that it crossed paths with Axostemis the turtle, who, lurking in the dark waters, posed no threat to this small surviving mammal. Faced with these damaged but resurgent ecosystems, the world now belonged to the Masatma. As well as uncovering new species and specimens, like this Axostemis turtle that the team is carefully bringing back to the museum, the other mission of the dig is to precisely date the fossils, to understand the timing of their evolution.
Just let it go. Okay, watch your fingers, everybody, let it go.
It's down.
Okay.
The team needs to create a timeline using the layers of rock that make up the bluffs. The horizontal layers seen in the hills of the bluffs show the passage of time. Year after year, millennium after millennium, sediment has been deposited in successive layers. This stony layer was formed at the bottom of a river. The river moved over time and left a sandy bank on top of it. Here, a tree has grown on the bank. Then, after the river moved again, the tree was buried. The information in these layers allows the dating of when they were formed. By knowing the date of the layer, scientists can work out the age of the fossils they contain. First, the layer from the time of the asteroid strike has to be identified. It sets the date of 66 million years. It usually contains the dust of a high concentration of iridium from the meteorite which vaporized in the atmosphere at the time of the explosion. But the rivers that ran through the Coral Bluffs 66 million years ago washed away the soil and carried away all traces of this extraterrestrial event.
I think this is the asteroid blast.
Yeah. Kidding.
Tyler has called on French scientist Antoine Berkovici, who is a specialist in plant pollens. Antoine has spent much of his career identifying this layer from many places around the world, like here at the West Bijou site, less than 100 kilometers from Coral Bluffs.
There it is.
Yeah. It never ceases to amaze me. So down here we've got the age of the dinosaurs, and then above it we've got the age of the mammals. And right here, the biologic reset button.
And by putting our finger on this layer, we can do the same all over the world and point at that day in Earth's history.
Yeah.
To find our way through the depths of the Earth's history, science has created a geological timescale, divided first into eras. It then subdivides into periods. Dinosaurs ruled the Earth during the Secondary Era, now called the Mesozoic Era, mainly in two periods, the Jurassic and the Cretaceous. The asteroid impact 66 million years ago put an end to that rule and is the beginning of the Tertiary Era, or Cenozoic Era, whose first period is called the Paleogen. Man did not appear until 66 million years later, during the Quaternary period. This layer containing meteorite dust, iridium, marks the end of the Cretaceous period, the last of the dinosaurs' world, and the beginning of the Paleogen period, the first of the birth of our world, the world dominated by mammals. Scientists call this transition the KPG boundary, for Cretaceous-Paleogen boundary. In West Bijou, Tyler has taken Antoine to sample this layer for its pollens, to have a reference when analyzing the KPG boundary at Coral Bluffs.
Ici, je suis en train d'échantillonner cette coupe de West Bijou pour étudier les successions de spores et de pollen fossiles. Donc je prélève des échantillons de roches, centimètre par centimètre, pour voir justement où est le niveau d'extinction.
66 million years ago, just before the asteroid struck, West Bijou was a stagnant swamp. The iridium dust from the asteroid floated in the atmosphere and eventually settled in the swamp in a thin layer. But there's more. The spores of ferns, fungi, and plant pollen were also carried on the wind and mixed with the sediment. For a paleontologist like Antoine, this layer is incredibly rich in information.
On peut la voir ici, sous la forme de ce niveau blanchâtre. Et donc on va pouvoir échantillonner et comparer les flores qui sont en dessous et les flores qui sont au-dessus et voir le niveau d'extinction. À Coral Bluff, on n'a pas la limite Crétacé-Tertiaire directement visible. Donc on va utiliser des microfossiles, les spores et les pollens, pour essayer de la trouver, car il y a une extinction des plantes au niveau de la limite Crétacé-Tertiaire. Et donc certains types de plantes disparaissent.
By revealing this layer marking the extinction of plants, Antoine Bercovici, even without the help of iridium, can locate the prized KPG boundary, the first mark on the timescale hidden in the hills of the Coral Bluffs.
Loaded up with samples.
I'm carrying them all. All right. Let's go back.
Onward.
To create this geological timescale and determine the age of the fossils, other time markers have to be found. Geologist Ken Weissenberger uses another tool to date the age of rocks: paleomagnetism. The Earth's core is made of ferrous metal, making it a gigantic magnet. But throughout its history, the direction of these magnetic currents has reversed many times. Scientists have dated each of these reversals and created a timeline of these changes. In Coral Bluffs, Ken Weissenberger has been tirelessly collecting samples for paleomagnetic analysis to determine where in the rock record the magnetic inversions occur.
Here we have some sandstone with some black bands of magnetite that is a natural magnet, and we have this magnetite in all the rocks in Coral Bluffs.
Each piece of rock keeps a trace of these inversions, essential information.
And magnetite is very excellent for recording the compass direction at the time that that sediment was deposited. And it makes it very efficient for us to sample here and take samples into the laboratory and to unlock that magnetic signal from 65 million years ago.
In the rock record at Coral Bluffs, geologists have found two magnetic inversions that frame the first million years after the asteroid impact.
Yeah, so Jake, right below that green bush, we have one of the paleomagnetic reversals out here. We know that right there, the rocks are roughly 300,000 years after the extinction of the dinosaurs. So it helps date all the fossils out here.
Yeah.
A final step will allow them to precisely date the fossils: a high-resolution digital elevation model of Coral Bluffs, as well as the GPS location of the fossils. To do this, a map of the geological layers needs to be drawn up. By logging a GPS position of a fossil collected on this map, paleontologists will be able to determine its age to the nearest 10,000 years. But how do you map out such a large area in high resolution?
Hey, Mark.
Hey, Tyler. Good to see you.
Good to see you, Matt.
Good to see you again.
The team and I, we've been working the bluffs just behind you here, and we found some really incredible vertebrate and plant localities there. Would love it if you guys could do some drone work so we could get better age estimates for those fossils.
Yeah, we'll be able to fly the drone and get some great data.
My crew and I, we can help set down some ground control, and then we'll let you guys get to work, huh?
The discoveries of Tyler Lyson's team have created a lot of interest. Mark Bauer and Matthew Burgess of the United States Geological Survey, USGS, have decided to lend him a hand. They are capable of making a relief map of the outcrop with an accuracy of up to 1/10 of a centimeter, thanks to the use of a drone equipped with a topographic laser radar, also known as LiDAR. First step for the geographers is to put the markers on the ground.
This arrow point will allow us to tie our imagery to the ground. We just set this point here, press this button, we let it run. At the end of the day, we'll pick these up. Maybe you can help us by distributing these throughout the area.
Well, let's go lay them down.
Whoa.
One last check before the flight. The wind might affect the mission.
This is currently 13 with gusts to 30. We're just on the edge here, but everything else looks good.
Yes, we're going to have to.
But Mark and Matthew decide to go ahead with takeoff.
Okay, arming. Okay, taking off. Okay, rotating.
Rotating.
Fighting against the wind, Mark still manages to scan an area about 400 meters square with one flight of the drone. Passing through the vegetation, the power of the LiDAR maps the terrain down to the smallest stone. Once the area has been mapped, Mark and Matthew start again on the next square.
Bring her lower. All right, I'll bring her back.
It will take several days of work to record the entire 28 square kilometers of the Corral Bluffs field area. From the drone data, and after computer processing, Tyler and his team will finally have a 3D model of the topography of Corral Bluffs, a unique tool for dating fossils. By combining the geological data, the KPG boundary, the two magnetic reversals, geologists can finally build the time scale over the entire Corral Bluffs field area and confirm the age of the very first animal and plant fossils that survived the asteroid impact. Thanks to the GPS data, Tyler can date this concretion, which contains a mammal skull, to just over 300,000 years after the impact.
Every year, when it rains or after the winter thaw, these concretions erode out of the hills behind me, and they roll down, and after a new rain, we're able to pick up new concretions, in some cases find extraordinary fossils inside.
He still has to determine which animal is hidden in this mineral concretionary tomb. Only once the concretion is removed will this fossil reveal its secrets.
Hey, Natalie.
Hi.
So here's the skull that we found,
Wow.
and I was wondering if we could get it in the prep queue.
Holy cow, the exposed bone looks really nice.
Yep. What's the game plan?
So I think I'll start by peeling back this over the top of the skull, expose the nice smooth bone, probably get rid of this little part of the concretion. Work on the teeth last. It should prep pretty fast. Looks like this operation's great.
Take you a couple hours, huh?
Have it done at the end of the day.
All right, well, let you get back to it.
Thanks.
While waiting for the fossil to return from the pre-lab, Tyler takes the opportunity to analyze the extraordinary remains of these amazing fossil animals. A fabulous menagerie. First unearthed in 2016 and enriched with new species and specimens with each digging campaign.
Mammal fossils are really easy to distinguish from all other vertebrates, all other animals. And you can do so by simply looking at their teeth. Mammalian teeth are very complex with lots of cusps and bumps, whereas most other animals have very simple teeth.
These mammals' teeth also provide clues about their diets.
Plant-eating mammals have very broad and sort of flat teeth that's well adapted for crushing and processing plant matter, whereas carnivorous mammals have much higher and pointier premolars for processing flesh. So some are pretty tricky because you can see this particular animal here has very sharp pointy teeth in the front and then very blunt teeth in the back. So this animal was probably an omnivore.
Beyond these bony remains, what could all these survivors have looked like? Tyler, together with Gussie McCracken, paleobotanist at the Denver Museum, has a very clear idea.
Do you want to go see what some of these mammals looked like?
Yeah, let's take a look.
Cool, let's go. This is a relief map of our field area at Corral Bluffs, and you can see all the valleys and the hills.
Wow, this is our field area. And this line represents the KPG boundary at 66 million years ago when the asteroid hit the Earth.
Yeah, this line marks the dinosaur world from the world after, the world that eventually gave rise to us, humans. So below that line, we find lots of dinosaur fossils, and above that line, we find no more dinosaur fossils.
All of these markers represent the fossils that we've been finding. All of the plants and the animals.
Exactly. This is one of the mammals that survives the mass extinction 66 million years ago.
It's tough to tell who it is based on a tooth.
Yeah, it is tough to recognize, but this fossil tooth belongs to an animal called Mesodma. And this is what it looks like.
It sort of looks like a mouse.
Yeah, it actually belongs to a group of animals called the multituberculates. And multituberculates go extinct about 35 million years ago. And Mesodma was about 20 centimeters long and weighed just a few dozen grams. Other multituberculates have been found in burrows, and Mesodma may have been a burrowing mammal as well. And another thing, Mesodma likely ate dead plants and seeds.
So by burrowing and being an omnivore, that's probably how Mesodma survived the KPG. Unlike other animals that are specialists that only eat one thing and have a higher chance of going extinct. So is this the mammal lineage from which humans arose?
No, we're descended from another group of mammals called the Plesiadapiforms. The earliest known Plesiadapiform is an animal called Purgatorius, who was first found in Montana at a locality called Purgatory Hill, where it thrived in the immediate aftermath of the extinction of the dinosaurs. Here's a tooth of Purgatorius, and this is the lineage that eventually gave rise to us, humans.
So what did Purgatorius look like?
Well, here it is.
That doesn't look like a primate yet. It looks more like a squirrel with a long tail.
Yeah, it likely lived in trees and was omnivorous. The group quickly spread throughout the world and eventually gave rise to us, Homo sapiens, some 66 million years later.
I'd like to look at another. Oh, that's Carciopticus.
Exactly.
I love Carciopticus. Kind of reminds me of a pig.
I mean, you're not wrong. He's an early herbivore and a member of the ungulate family, which are hoofed mammals that include modern-day horses, cows, and pigs. Carciopticus appears some 300,000 years after the asteroid impact.
Interesting. That's when we see forests bouncing back, and that includes the doubling of diversity for the walnut family, which includes pecan. I wonder if these early mammals were eating these high nutrient dense new plants. I mean, Carciopticus is so much larger than Mesodma.
Definitely. Carciopticus is about the size of a small modern pig, about 35 to 40 kilograms.
You know, with all of these new fossil discoveries at Corral Bluffs, it's telling quite a story. I wonder what Ornella is discovering studying the brain cases of these early fossil mammals.
Indeed, I'm really curious to see what she's discovered.
To find out more about the success of these early mammals, Tyler Lyson has called on Ornella Bertrand, a researcher at the University of Edinburgh in Scotland, who specializes in the brains of these animals. For the first time, and thanks to the site at Coral Bluffs, she now has many skulls dating from the first million years after the fall of the asteroid. With a revolutionary tool, Ornella Bertrand will be able to reconstruct the shape of the brain of these 65-million-year-old mammals. To find the imprint of the brain hidden inside the fossil, Ornella places one of these skulls in an X-ray scanner located in the basement of the university.
Hi again.
Hi, Ornella.
So I'm excited to look at some data right now.
Okay, so let's get the X-rays on and see what we can see. So let's just turn it around a little to see if we can get a better view.
I think that's good to go.
Okay.
The CT scan shows the internal structure of a skull without having to cut or damage the precious fossil. Using computer graphics, Ornella reconstructs the fossil in 3D from the thousands of images taken by the CT scan.
Alors à la sortie du CT scan, on obtient cette série de tranches. Ici, on en a à peu près 1500. Et grâce à ces tranches qu'on compile ensemble, on obtient un modèle en 3 dimensions de notre spécimen. Après que l'on ait obtenu le crâne en 3 dimensions, on est capable de reconstruire l'empreinte du cerveau à l'intérieur de ce crâne, que l'on voit ici en couleur. Et ensuite, on est capable d'interpréter la forme du cerveau.
By comparing this brain with that of the species still living, Ornella can recognize the portions of the brain that have specific functions. And by comparing them with today's mammals, she can deduce the behavior of these animals that lived over 65 million years ago.
Alors les mammifères qui ont survécu l'extinction, il semblerait qu'ils n'avaient pas des cerveaux qui ont beaucoup changé par rapport à ces mammifères qui vivaient avant l'extinction. Par exemple, ils avaient des bulbes olfactifs que l'on voit ici, qui n'ont pas beaucoup changé. Donc on peut penser que finalement le sens de l'odorat qui était assez développé chez ces animaux pouvait les aider à trouver leur nourriture et des ressources dont ils avaient besoin pour survivre.
Thanks to the incredible number of fossils from Coral Bluffs, Ornella Bertrand has discovered a major aspect of the origin of the modern world after the asteroid impact. Analysis of their brains reveals that the evolution of these mammals has taken a very surprising path.
Alors on s'aperçoit en fait qu'il y a une augmentation de la masse corporelle et de la taille du cerveau, mais que le corps finalement augmente beaucoup plus rapidement que le cerveau. Donc ici, vous pouvez voir qu'on se rend compte que la taille du corps augmente, donc ces animaux sont de plus en plus gros, mais la taille du cerveau bien sûr augmente, mais pas assez rapidement. Et donc, vous pouvez vous rendre compte ici que, à la fin, on a un animal qui a un plus petit cerveau par rapport à son corps comparé à celui ici.
The modest size of the mammalian brain during the first million years after the catastrophe points to behavior that didn't need a highly developed one.
Alors les mammifères qui ont survécu l'extinction, ils avaient une partie du cerveau qui était relativement plus petite par rapport au reste, et c'était le néocortex, qui est le centre où on voit apparaître des comportements complexes. Donc ils n'avaient pas forcément besoin de développer des stratégies complexes pour obtenir la nourriture dont ils avaient besoin, parce que les niches écologiques étaient complètement ouvertes et il n'y avait pas de concurrents finalement.
This data shows that these survivors had not yet been faced with strong selective pressure and fierce competition between species. They did nonetheless have to face predators, but there were many safe environments and still empty habitats they could use. During the years of twilight that follows the total darkness of the nuclear winter, the rays of the sun again reach the Earth's surface. The first forms of vegetation come to life. The successful evolution of opportunistic omnivorous mammals is still closely linked to the rebirth of the plant world, But other species contribute to it as well. These very first plants are home to a wide variety of insects. And these small creatures are a much richer source of food for mammals. Thanks to this protein-rich food, they'll start to increase in size. The plants will also become stronger alongside the animals. Which plants survived? And how did they develop during the first million years after the asteroid? A question that is key to understanding the global mechanism of the renewal of life.